next thing in chapter 6 is going to be these trigonometric identities. So basically you can think of them as like trig proofs. Okay, it's kind of like your goal is to get one side to equal the other, and you know exactly what you need to get to. You just have to try a bunch of different methods to get there. So you have to realize you're not going to get everything right away. You may take 10 or 15 minutes to get through some of these, but it's kind of a challenge. So I know where you know where you have to get to. You just have to figure out the best way to get there. Okay, trying different things may or may not work, and you may have to start all over again. So eventually what we're going to do is try and take something like this and say, okay, how can I take this expression here and get it to equal 2 tangent? So I'm going to have to manipulate this thing somehow, add them together, so it's fractions. When you're adding fractions, you got to have your common denominator, and I'm going to have to get 2 tangents somehow. Or this is a real common one too. So how is a 1 minus sine over a cosine equal to a cosine over a 1 plus sine? When you do these, though, you have to keep these things in mind. You cannot be moving stuff between the sides. We know they're equal. It's like saying, 8 plus 2 equals 10, and going, 8 equals 10 minus 2. You can't just move something to the other side. We know they're equal. That doesn't help us. It's just rearranging things. These are not equations, so it's not a matter of do the same thing to both sides. So it's not like you can come over here and go, I'm going to multiply this by cosine, and then I'm going to come over here and multiply this by cosine. Okay, you got to get out of that mindset right now. With the identities, you can't multiply both sides by the same thing, and you got to be very, very careful manipulating the sides. So a lot of the stuff comes back to basic fraction stuff. Can you add fractions? Can you subtract fractions? Can you factor? Can you do fractions within fractions? Okay, so it's not the trig, it's the basic skill stuff with that. You may remember on the skills worksheet we started the year with, I gave you this. It probably didn't make a ton of sense at the time, but these are actual student things that we saw, and we want to talk about, why they're incorrect. So these don't have an equal sign in them. They're not true identities. They're just expressions, but you have to start with the expressions before you can move on to the identities. So something like this, sine plus a sine squared over a 1 plus a sine. You can't do that. What you can do is realize this has a GCF, pull the sine out, you're left with 1 plus sine, and those will cancel. Okay, it's just a basic math thing there. It works the exact same with x's or y's or a's or b's. We're just inserting trig functions. You get here, 1 minus sine squared over 1 plus sine. You can't just cancel stuff out, just like you couldn't in college algebra. Don't do that. But 1 minus sine squared is no different than 1 minus x squared. It's a difference of squares. So 1 minus sine times 1 plus sine. You double distribute, middle terms go away. Now that'll cancel, and here's what you're left with. Double distributing. If I told you to do x plus 1 quantity squared, don't tell me this. Get the middle term in there. Actually write it out, double distribute everything, and collect all the stuff. An expression like this, sine theta times cosine theta over 1 plus sine, you can't just randomly cancel those signs. It doesn't work that way. There's nothing you can do with this. So these are missing the thetas in there. You have to just leave this alone. Nothing you can do. This will come in when we get to the second half of chapter 6, but I did see a lot of this. Don't give me that, okay? Leave answers like this. So really, really make an effort at doing these basic skills things. All right, before we can do anything like this, we have to just work on some simple expressions. So the book and the exercises to start out tells you to do very specific things. I think the best way is I'll do the evens, and then to start class, I'll have you guys do the odds of these. So on 471 here, I'll write the problems down. You guys are going to do the odds in class tomorrow. So first thing I'd ask you to do, rewrite something in terms of sine and cosine. So they'll give you a simple example here like this. Okay, you're just replacing in sine and cosine. It's one of the more helpful strategies when you're doing these identities. If you're stuck, rewrite it in sine and cosine. All right, a cotangent is 1 over a tangent, or it's a cosine over a sine. We could also take a minute here and say if you did write it as 1 over tangent, that's 1 over sine over cosine, fractions within fractions, 1 divided by sine over cosine becomes 1 times cosine over sine. So basically this cosine just gets to swing up top. Okay, but there's a reason why. All right, so now that we've rewritten cotangent as cosines over sines, a secant is the exact same thing as 1 over a cosine. These are on the diagonal. They can cancel. Your final answer, 1 over sine. Or you could say cosecant. It doesn't really matter in that case. So maybe a simple identity would be, say cotangent times secant equals cosecant. And all you would have to do is do this and prove this side equal to the other. All right? Next question asks you to take an expression and multiply it by a common denominator, or the exact same thing. The reason we can do this is this equals 1. So we're not changing the equation at all. It's the same idea as if I said, okay, I'm going to multiply 1/2 by 5 over 5 and say it's 5/10. It's the exact same thing because this expression right here is just a 1. So we want to take this, we want to multiply it by 1 minus cosine over 1 minus cosine. That's allowed. So this would be an example of like trying to get a common denominator. I'm going to put parentheses around those because it's important there. All right, we're multiplying two fractions here, so we just need to see what happens. Now it's going to be convenient sometimes to not actually multiply through, and as you do more of these, you'll see when you want to do that and when you don't. So in this case, I'm going to leave the top as this. I'm not going to multiply that through because I know something's going to cancel. You could write it as a sine minus a sine times a cosine, but that's not going to help you. Now on the bottom here, you're going to have to double distribute. This is like 1 plus x times 1 minus x. So this is 1. You get a minus cosine in the middle. You get a plus cosine in the middle. Those will go away. And then lastly, you get cosine squared, minus cosine squared. All right. You may think this is done, but there's a little simplifying you can do. All those Pythagorean identities, all the reciprocal identities, all the substitutions now come into play. 1 minus cosine squared is the exact same thing as a sine squared. And that comes from the most basic identity we have, this. So we're simply, if you move the cosine over, what's left? Just with the sine squared. Now when you do that substitution, you can see why I didn't distribute this. Because I knew something would cancel. A sine over a sine squared, that cancels right out of there. So this turns into simply just this, 1 minus cosine over a sine. So that's actually one of those identities I gave you earlier. So we said, take this, multiply it by 1, basically, and I turned it into those. So those are equal expressions right there. Here is a common denominator one. It's not equal to anything, So this would be, a simple identity, and it would say equals something over here, and you just have to prove it. But the whole idea is you have to be able to write this over a common denominator. Okay, it's not cross multiplying here. You're not doing that. If I ask you to add 1/2 to 1/5, you're not cross multiplying. You're saying 1/2 and 1/5, the common denominator between them is a 10. So I'm going to multiply this by 5 over 5 and this by 2 over 2. So this becomes 5/10 and 2/10 is 7/10. It's the exact same idea. There is no cross multiplying. You can only multiply by 1. So common denominator in this case was 2 times 5, exactly the same here. That times that. So yes, this expression over here needs to be multiplied by a 1 plus a cosine, but it's a 1 plus a cosine over a 1 plus a cosine. This expression over here needs to be multiplied by 1 minus cosine, but it's a 1 minus cosine over a 1 minus cosine. There's a huge difference between that, and if you can't do common denominators, you're really going to struggle with these identities. So now what do we have from here? On the top, multiplying by 1 makes it pretty easy. 1 plus a cosine. On the bottom, you'll see a lot of these difference of squares. Just like the last one we did, middle terms are canceling, but make sure you pay attention to those signs. And there's our common denominator. They're asking us to add them. So now again, a 1 on the top makes this pretty nice. Now, again, these are difference of squares, so we know the middle term's going to cancel. You won't always have that case, though, but now you get to here. So now you look at it and you say, okay, my denominators are exactly the same, so I can write it over one of these expressions, and then you add the top. So 1 plus cosine, 1 minus cosine actually just gives you 2. Because those cosines are going to cancel. You could leave your answer like this, or, because it's good practice, a 1 minus a cosine squared is the same thing as a sine squared. So you'll see that in the identity a lot. It'll ask you to prove that initial thing may be equal to 2 cosecant squared, because that's what that really is. Here would be another very common identity. So they'd give you, a lot of stuff going on one side, and they could simply say equals sine or whatever it is. I have no idea. You would just have to prove this side equal to whatever they tell you. So we just want to work on trying to simplify these things. Okay, this is a multiplication problem. So let's do some double distributing. Tangent squared plus a tangent. Notice this is not a difference of squares, so you are going to get some middle terms. Copy the minus secant squared, put this entire thing over a tangent. Now, you can't just randomly start canceling tangents out all over the place, because the tangent, yeah, sure, it cancels here, here, and here, but it's also underneath here and underneath there. So don't be doing that. Okay, collect like terms, and let's see what happens. So I got a tangent squared of theta plus 2 tangents of theta plus 1 minus a secant squared all over a tangent of theta. When you get to here, this is not as simple as it can get. Anytime you see things that are squared, think about your Pythagorean identities. So whether we have lots of things in tangent, so why don't we keep those? Why don't we go see what secant squared? If you go to your yellow sheet, you can see a secant squared is a tangent squared plus 1. So I'm going to do a substitution for that, but we got to watch out for that negative sign. So we block that off. And we go tangent squared plus a 2 tangent plus a 1 minus, in parentheses here, tangent squared plus 1. Obviously, this is still all over a tangent. Now, this is going to get distributed, and a bunch of stuff should go away. Okay, these expressions are going to become very, very simple things. So that becomes a minus tangent squared, which is going to cancel with that one. This negative goes all the way through. It turns that into a negative 1, which is going to cancel with that. So really, all you're left with is this over this, which is just 2. So the identity part of it would be this intro piece, and it would say equals 2. So you'd leave the 2 alone, you'd do this work, and you'd get that, and you'd be done. Lastly, a very common factoring problem. It says factor and simplify. So you have these things here. You can't just start randomly going canceling cosines. Okay? It doesn't work that way. But if you look at the bottom, you'll notice has a GCF, cosine squared and a cosine. So pull a cosine out, you're left with a cosine minus 1. You come to the top, that's no different than x squared minus 1. Sure, cosine squared minus 1 looks like it may equal a sine squared, but it doesn't, because it's 1 minus cosine squared that would actually equal a sine squared. So be very careful the orderings of those. So yeah, you could, well, I mean, that wouldn't even work either. Okay, so just make sure it exactly matches up like the Pythagorean identities from last chapter. Okay, so we're going to try and factor this. It's the exact same thing. So you get a cosine minus 1, you get a cosine plus 1, you double distribute that, middle terms will cancel. Now what you can do, this goes away, and your final answer is this. That's it. Nothing more you can do from there. To finish up, we're going to do 3 very straightforward identities, and we'll give you some more challenging ones in class. So this actually has the equal sign in here. Okay, you can't start moving stuff to the other side or dividing everything by sign. You can't do that. Literally, keep this side separate. This is a sine squared, so just leave it alone. That's pretty simple. So don't touch this at all. Don't even keep rewriting it. Okay, all you want to focus on is this side. There's different strategies you can use when you're trying to solve these. Here's a short list of different things you can do if you want to kind of keep that down as you're working through these. So a very helpful one is everything in sine and cosine. If you got fractions, adding, subtraction stuff, common denominators are helpful. You can replace with Pythagorean identities, but only with squares. If you see a 1 minus a sine, you can't go plug in cosine squared. That doesn't work. You're going to leave that alone. You can factor. Tons of stuff is going to cancel. And hopefully you don't have to end up with that last one there. So coming back to this. Sine times a cosecant. So I'm going to say, well, sine cosecant is 1 over a sine minus cosine squared. I'm just going to keep that exactly like it is. These cancel. 1 minus cosine squared is the exact same thing as a sine squared. Now I can drop this down and just box up both of them, and my job is done. So it was a one-step one. In the next part, we'll do the last 2 as quick as we can.